Right, so technology has certainly pushed some fields to their limits, and healthcare is no exception. From wearable devices that monitor our health and help in rehabilitation processes, to programs and predictive technology able to detect illnesses early on, with the aid of big data and data science, we're seeing big leaps being taken in the healthcare sector. In light of these advancements, the Carol Davila University of Medicine and Pharmacy from Bucharest has launched a series of actions to develop training programs for their faculty, where they're also focusing on big data analytics. Join me in welcoming Octavian Andronic, coordinator of the Big Data Analysis Department of Innovation and eHealth at the Carol Davila University of Medicine. He's going to talk to us about the benefits that technology can bring towards a better, healthier life. Thank you.
Hello. Hello, everybody, and thank you for inviting me to this event. So, my name is Octavian Andronic. I'm an assistant professor at the University of Medicine and Pharmacy and the coordinator of Big Data Analysis Department from the Innovation and eHealth Center of our university. It was very hard for me to set up this presentation because in the public there are a lot of technology persons, a lot of persons who have a lot of knowledge regarding data and technology, a lot of knowledge, and we are only at the beginning of the road for using technology in our activity. So in a few minutes I'll talk you a short introduction. Then I'll try to answer you 5 questions. Why we try to use big data in healthcare? What do we have in this moment? What can we do? What we don't have? And what we would need. You surely know that in 2013 we are talking about a volume of exabytes. Only 3 years later we are talking about zettabytes. And today's volume of data is about 100 zettabytes. It's a very, very big amount of data. Somebody said that it's like today's data, every person on Earth would have 300 times more information than it was in the ancient library of Alexandria. So it's a lot of data. It's impossible to be analyzed by statistical methods, classical statistical methods. The Innovation and eHealth Center of our university was founded last year. It had and it has 4 departments: Digital Solutions and Innovative Technology, Big Data Analysis Department, Artificial Intelligence in Healthcare, and Entrepreneurial Hub. The aim of this center is to give know-how to students and our academics, to teach them about technology, about digital products, about digital technologies, and how can we use them to make some research and to innovate in all of our activity, didactic activity, research activity, and medical practice. Why we should use big data in healthcare? Every improvement we do to our healthcare system is to improve the quality, its quality. There are a lot of objectives we can be focusing when using a new technology. For example, early detect of the diseases or detect the illness before it begins to be symptomatic for the patient. We have to improve the decision-making process to be an evidence-based one, and the big data can help us to have more accuracy on decision-making process. To move the center of our approach, of our medical approach, from the disease to the patient, to help us to have a personalized medicine, a personalized management and the therapeutics of the illness. And all this goes straight to cost reductions and efficiency of our systems. As you can see in this picture, even if we use a holistic approach, where every entity is only a part of an ecosystem, of a big ecosystem. If we go very deep to molecular, submolecular, even atomic dimensions, the only way to have accurate results, to have concrete results, is using big data analysis. It's impossible to have some true results using classical algorithms and classical statistics. Scientific publishing is a very good, a very good, a very good, a very good example, and a very good, I don't know, use why or how much the data from research and medicine have grown in last 20 years. Only last years in Web of Science is the database where only about 20% of all published articles you can find have published more than 2 million articles only in medicine. That means about 5 articles per minute published in world only in Web of Science database. So it's a lot of data published, and the published data is only a little part of the data collected in a research. So there is a lot of waste of data. Here you can see the number of articles published regarding use of big data in healthcare, and in less 10 years, the growth of the number of articles is exponential. So the big data definition initially had 3 V's: volume, velocity, and variety. Then another 2 V's were added to this definition: value and veracity. So let's see how healthcare services are in this definition represented. Regarding the volume, you can see from the presentation from Regina Maria that the volume of data is enormous in a healthcare system. For example, in our hospital, Emergency University Hospital of Bucharest, at the emergency room only, we have about 300 patients per day that are producing 5 megabytes of data per day, only alphanumeric accepting images. That means we have 2 gigabytes of alphanumeric data per year only on one hospital from Romania. Images produced by medical imaging are very big. For example, a simple digital radiography, it's up to 18 megabytes. At the emergency room of the same hospital, we do about 500 digital radiographies every day, about minimum 10 computer tomographies per day, and minimum 200 ultrasonographies per day. That means that we store about 20 giga of information each day from medical images. Regarding genomics, I don't want to insist because, as you know, a human genome for one person is about 2.9 gigabytes of data. Wearables and the smart devices are new technology that produces a lot of information. The simplest devices, wearables, can record heart rate, blood pressure, and oxygen saturation. In Romania, last year were sold about 50,000 smart devices. That means that only these devices produces about 50 gigabytes of information per year only in Romania, and using only an estimation of a few number of persons using them every day. So some statistics shows that 30% of the world data volume, for the volume of data I have presented in the start of on the beginning of the presentation, is produced by healthcare, by research from medical research. Every patient produces about 80 megabytes of information per year, and all healthcare system produces about 1 million terabytes of data every year. So I think that the volume of the definition of big data is very good, has a very good representation in healthcare systems. Regarding velocity, I have presented you some little insights regarding one hospital. So we have real data produced by clinical and biological equipments, medical imaging, and wearables. We have a lot of data structured and not structured from various sources, manual entry from students, from researchers, from radiologists, for example, and we also have machine-generated, automatic, generated data. The accuracy of the data can vary a lot, from patient survey that is not so accurate to machine-generated that can be, but it not in every case, be very accurate. The value of the data in research, we have this pyramid of relevance of every study. Unfiltered information like case reports, cohort studies, and even randomized control studies produces studies with relevance lower than meta-analysis and systematic reviews. And in this pyramid, where we can find the big data analysis? I think that big data analysis is the point from the top of the pyramid, because it gathers information from all the sources, and the accuracy and the relevance of this data is very, very big. So what do we have? We have a lot of data, but data is not information, and information is not knowledge. From acquisition of the data to knowledge, we have to go through a big process, big steps, processing the information, selection of the features for each class of data, classification of data, and then from classification we can extract some knowledge. In healthcare big data usage, you can find problems in each of these steps. So what do we have? We have a lot of data: clinical data, lifestyle, environment, genetics, pharmaceutical, imaging, biological. You have even social networks, data that can influence the healthcare of the well-being of the persons. Big data is the intersection of all these types of data. So to study what happens with the people in this holistic system using all this kind of data is possible only using big data analysis. More concrete, what do we have as University of eHealth Center of Innovation and eHealth? We have clinical data from electronic health record exported from data centers of public and the private sector hospitals, exported to cloud. We have bought recently some cloud space from Amazon. Then we have a lot of data from clinical trials. We can merge them and meta-analyze them. We have a lot of medical imaging that are not used in any research. We have some genomics data from the ROMCAN project. We want to bring them to Romania as soon as possible. And we have a lot of data from online questionnaires from patients. What can you do? What can we do? I'll show you some examples of projects that we are starting now, and we hope to finish them in next year or 2 years regarding this prediction of mortality in sepsis patients, prevent heart events during surgery, cancer management, optimization of medical services, and to ensure a better and faster diagnosis. Some examples on prediction of mortality in sepsis patients. If you have a patient admitted to intensive care unit, with black line we have represented the patient's status from admission to ICU to the death of the patient. If we can predict the mortality of the patient in each moment, we can see that is one point when the doctor thinks that the symptoms are ameliorating, when the prediction of this is very big. So if in this point we could predict that we have a problem, we can change the therapeutical management, and the output of the patient could be other. Another project we are working is the life EKG monitoring using IA algorithm that may predict heart events during surgery or on perioperative period. Every patient is monitored by EKG during surgery, but the acute events of the heart are very hard to to predict only by watching the doctor to the EKG. So we need an algorithm to predict in real time the cardiac events. Breast cancer management. Thank you. Sorry. Sorry. There are a lot of things we can do regarding cancer management, from prevention of early diagnosis of cancer, to histopathological features and to clinical correlations using big data analysis. For example, you all know that in occurrence of breast cancer, there are two big genes that we study, BRCA1 and BRCA2. But in reality, there are more than 150 genes that are studied regarding early prevention of breast cancer. But we can't study human genome without big data analysis. Breast imaging. In the image from the left side, you can see a normal breast. In the right image, you can see a breast with 100% malignant tumor. For any expert in breast imaging or in breast surgery, it's very easy to say that is a normal breast and a malignant one, a malignant tumor in the right side. But here are some borderline tumors. It's very hard to say if it's benign or malignant tumor. So, in order to tell with big accuracy where we have a tumor or where we don't have a tumor, we can do it without some intelligence, artificial intelligence or machine learning. Histology of cancer. Here are some immunohistological pictures. In these pictures, you can see a lot of features of the tumor. But there are a lot of other features that are not visible for your eye or for an expert eye. These features can be seen with the help of intelligent artificial intelligence. Clinical studies. The red dots are outliers of values. It doesn't matter what represents in this image. We say something about the disease only for the patients that are in that structure of patients in the left side of the image. But if any of that red dots are 1,000 of persons, we can characterize very well that lot of patients, and we can tell why there are not in the lot of the other persons, the normal distribution of the patients. Another project we'd like to start is regarding emergency room efficiency. The emergency room data is a very big volume of data, continuous growing, impossible to analyze using classical algorithms because there are a lot of heterogeneous data. So with the help of big data analysis, we can make faster diagnoses, we can use fewer tests, so the treatment could start earlier, and the patient's comfort would be and chances for a favorable outcome would be much more, and we can save a lot of money because the emergency room of a hospital costs are the biggest costs from any hospital. For example, in this example, using our protocols, there are a lot of patients, blue or red, which diagnosis will be wrong or will not be full, or will not have a full diagnosis. Only using advanced machine learning analysis, we can correct diagnose each patient, and in this way we can save a lot of resources, a lot of money, and the healthcare system quality to grow. Brain MRI. There are a lot of small tumors that is very hard to say if they are malignant or benign. There are a lot of tumors we can't say if it's primary or metastatic one. Cerebrovascular events are not seen in regular CT scan or MRI scan in few hours after they occur. So using intelligence artificial, there are a lot of examples in literature. We can see these events much earlier and with very good accuracy. We have big data, we have big problems. Regarding clinical data, we have a lot of unstandardized results. For example, the results from medical imaging that we have from the radiologist are unstandardized. We don't have a standard, a protocol to report the findings from medical imaging. So we have to use natural language processing to ensure that all the data are in the same report in the same way. There are a lot of different scale on different equipments. Every hospital have another equipment from another provider that has other scales for reporting and result. We have a lot of analog data. A lot of data are not in the electronic health record, are only on the printed record of the patient. There are a lot of data wasted that we cannot use because they are not digital yet. We have a lot of missing values and inconsistent data, and maybe one of the biggest problems are legal issues. When and how can you use the data of the patient for research? Regarding imagistic, there are a lot of bad acquisition of images, and genomics, it's very expensive to do genomic sequenciation for patients. What we don't have data science experts in our university. We don't have a curricula for students and academics regarding digital health and use of technology. We don't have protocols for data acquisition. We don't have a legal frame in Romania to help us take the data from hospital, from public hospitals, and we don't have enough money. What do we need? We need partners from data science field. So this is an invitation for all of you if you want to help us and to help us growing the quality of care, because you have the know-how. We need your know-how. And we need funding opportunities to can manage projects, private and public partnerships, found them to have good results. So thank you for listening to me. And this is, again, an invitation for all of you, if you want to collaborate with us, to make some interesting projects.